Hey everybody, welcome to this show, I guess you could say. Basically, I wanted to show y'all my first debugging that really actually has ever worked. I was watching a little bit on how to debug, and you put a little thing over here by just clicking, and then that sets a breakpoint. So as you go into this menu, start without debugging or start debugging. I usually hit Control F5 and just run the program without debugging. But I was having trouble with this. Well, let me just show you. I implemented a program where there's going to be a maze on the screen, and this is actually a maze over here. These are not mazes. The maze is in the background, and it's not being displayed. It's just in memory, computer memory. And based on the path through the maze using Dijkstra's algorithm, thank you for how I say that. Anyways, there's a random spot that's chosen in the maze, and then using Dijkstra's algorithm calculates the path between that spot and every other spot. And it goes, yeah. And anyways, what I was having trouble with was the actual colors were blending too much. Um, so like I'll show you what they were doing because I can just take out the change that I put in here. This modulo 60. There, so I'm just going to take that out. So this is the what I'm doing is using the calculations from Dijkstra's to modulate the color component. Right here, this is the calculation from the Dijkstra's algorithm divided by the greatest number that it came up with. And so that created a number that basically cycles from 0 to 1. And then here I'll just recompile everything and show you the difference in the maze. See, so here's a nice little, it's kind of like a little hill or mountainside, I guess you could say. Looks kind of cool. Anyways, my goal was to have a different algorithm represented in different quadrants of the screen. And my next algorithm, this is the binary tree algorithm, which obviously has a bias, which is on a diagonal, but that's in the book. And the next one's going to be the Sidewinder algorithm. And that'll be interesting because this one took me, that's why I haven't posted a video for a while, is because this one took me a while just to think about it. And I can kind of walk you through what I did. I created an enum, my first official enum outside of OpenGL just for an algorithm. Basically, I wanted to be able to use N, S, E, W, and visited in the array that I use for this. Anyways, it all happens inside of a init. Everything happens inside of a init. None of it happens inside the any other part of the program. So, so there's some booleans that I created for north, south, east, and west for the doors, or the walls between the cells, if you will, of the maze. Basically, if it's false, that means that there's a wall. If it's true, that means there's no wall. And then the visited is just on or off. Has the cell been visited, but that's not used until the Dijkstra's algorithm. So this array is not for the creation of the maze, but after the maze has been created, and then this is used in the Dijkstra's algorithm to run through the maze and figure out how the colors are supposed to be gradient. Initialize the maze before running the algorithm. Reset the maze. This is where the initial variable goes to the front. It's called the frontier in the Dijkstra's algorithm. Set all cells to false. Anyways, northern wall. There's a bias in the algorithm, so this was a pretty easy initialization because you can set the northern wall and the eastern wall to be just open. So I set all the doors to true um, because the binary tree algorithm leaves just an open hallway on the north and eastern side of the on the mazes that it generates. Anyways, east wall. And then the binary tree algorithm actually happens right here. It cycles through the maze. You notice that I don't hit the last row or the first row or the last column. Anyways, each cell choose for each, it cycles through every cell aside from those two hallways in the maze. For each cell, choose north or east. I use random, just 1 or 0. And if it's 1, then the north wall comes down, sets the actual variable north for those coordinates to true. And then goes, since it's going north, it's going in the y direction, a negative, and then sets the southern wall on that cell to true. And then basically do the same thing with the east wall. And so each cell it lands on, it decides whether the north wall is going to come down or the east wall is going to come down. And that's basically the binary tree algorithm. And then I go through the whole maze. And then temporarily fill in random colors per quadrant. So this is for all 4 of the quadrants of point sprites. One thing that was interesting is setting all the point sprites, all the 4 quadrants on the screen. This was the temp index I used to index into the vertices array. So anyways, what I did was I ended up having to use that down here as well. Even though I wasn't, or wait, yeah, right here. Even though I'm not cycling through those, I'm only cycling through up to 90, but the index into the vertices array is like, yeah, I had to modify that. So that was the only thing that kind of, it threw me off for a second or so. And then now since I'm modulating, did I add the modulating back in? No, we better add that back in before I forget. Oh wait, I wanted to show you the debugging too. How could I forget that since this is working like this? So I wanted to know how high current frontier got because of the colors and the way they were being represented. See? So what I did was I just started debugging and run it to here. And then all you have to do is just highlight over the variable you want to know. It says it's 186, right? So current frontier, calculating that quadrant, got up to 186, which means there's, oh wait, stop debugging. There we go. Which means that as it's going through and calculating all the steps, there's 186 different colors being represented out of the 256. So to make it a little sharper, you take this number, which goes from 0 to 186, right? That's what I was doing. And then modulate it with 60. So now instead of going to 180, it goes to 0 to 59, 0 to 59, 0 to 59, like that. And so it gives you, there's actually 3 separate beginnings of the, it starts at the darker color and goes to the lighter color. So 3 separate beginnings. And it's really, this is just cool. I actually have the latest thing right here on my background of my computer because I just think it's pretty cool. Anyway, so stay tuned for more cool maze things. I'm going to nerd out on mazes for a while. I'm not forgetting about the video game. I'm actually just kind of nerding out on mazes, and I'm going to make a better logo with mazes and stuff. So thanks for watching. Be sure to like and subscribe, and also leave comments below the video. Thank you again.